and minimize my page. The note said you wanted to deal with trig expressions, converting them to algebraic expressions.
Yes, I just sent you an email with 2 problems in it.
Okay, let me pop open my email. Let's see if I can have a look. Yeah. Okay, let me download that first of all. Getting used to this new GoToMeeting that they sent me that I don't like at all.
It does appear to have changed quite a lot.
It does, and I'm not used to it yet. It takes up your whole screen. It's hard to. Okay, I think I can work on this. Let me open my tablet so that I can write on here. Write each trig expression as an algebraic expression. And I assume the blue is the answer?
Yes.
Okay. So, let's see here.
So, yeah, apparently there's a way to do it with using triangles and geometry. Yeah. But I was trying to do it the other way.
Well, the only way, first of all, it's important when you see problems like this to understand that that is theta. That is an angle.
Okay.
When you see an inverse trig expression, it's an angle. In other words, we take cosine or sine of theta equals 1/2. So we take trig functions of angles to get ratios, and we take inverse trig functions of the ratios to get angles.
Okay, that makes sense.
So it's useful to look at that as an angle. And now if we draw a triangle where that is the angle we're talking about, and the ratio would be u over 1.
Okay.
Now, using the Pythagorean Theorem, we can figure out the other side. Do you know how to, I mean, you're looking at the answer, but it's a really good skill to be able to solve right triangles quickly without going all the way back to the Pythagorean Theorem. In other words, let's just a squared plus b squared equals c squared. And the 2 key ones that I like people to be able to get to directly is the hypotenuse is always the square root of the squares of the other 2 sides. But either short side, let's say b, is the square root of the hypotenuse squared minus the square of the other short side.
Okay.
And so these 2 right there are very, very useful to go directly to. In this particular problem, we're solving for the short side, right?
Yes.
So what is it? It's the square root of?
Square root of 1 squared, or 1 minus u squared.
Okay. And now, looking at this, we can see that the cosine of theta from that triangle is that divided by 1.
Huh. Okay.
Okay. Now, when you said you wanted to be able to do it in a manner without using triangles, you're talking about like memorizing?
Well, no, using trig identities to get there.
Okay. I'm not sure I know how to do that.
I could send you my list of identities if that would help. It's got like 5 or 6 of them.
Read a couple of them to me.
Okay. 1 second. Let's see. So they're just super easy. Sine squared theta plus cos squared theta equals 1.
Next.
Tan squared theta plus 1 equals sec squared theta.
Okay.
Cot squared theta plus 1 equals cosecant squared theta.
Okay.
And then the reciprocal.
Those are your three trig identities.
Yeah.
That's what they're called, is the trig identities. I'm not sure you can use them in this problem. At least I don't know how to do it.
Okay.
I go through the triangle method. And the triangle method kind of requires you to understand that this inverse sine of u is an angle, which allows me to draw that angle, and it also allows me to proportion it with 1 and u, because that's the ratio. It's u over 1 is what it really is.
That makes more sense. Okay.
And once I've done that, I can always figure out the third side using the Pythagorean theorem. And once you've figured out all three sides of the triangle, you can figure out what the cosine of theta is, the tangent of theta, the secant of theta, any trig function you want of that angle. They would all be different. In other words, what would the tangent of inverse sine of u be?
Opposite over adjacent, so u over 1 minus c squared, root 1 minus c squared.
Square root of 1 minus u squared? Yeah, it's as simple as that. In other words, once you've drawn the triangle and know where theta is, then you can do any of the trig functions.
Okay.
And we can use the same technique. Figure out where my eraser is for the second one. In other words, again, we know that that is an angle. So if we draw our triangle, cosecant is what? 1 over?
1 over sine.
Okay. So what parts of this triangle can I label? Excuse me, it's not 1. Yeah, it is 1 over sine.
So you can label the opposite side and the hypotenuse.
Yeah, and the hypotenuse is what?
Is 1.
In this case, it's actually u.
Okay.
Because the cosecant is the hypotenuse over the opposite side.
Okay.
In other words, it's the reciprocal of the sine. And the sine is the opposite side over the hypotenuse, so the cosecant is the hypotenuse over the opposite side.
Okay.
Okay? And
so
now
the third side.
We still have
the third side would.
The third side. Go ahead.
It would be the square root of u squared minus 1.
Now, how do they get that answer? There's something special going on there. You can see that in other words, now, if we said what's the tangent of theta, I would end up with 1 over the square root of u squared minus 1. But they actually end up with the absolute value of u over u times square root of u squared minus 1. Now, why is that? It has to do with the fact that this thing in other words, other than that absolute value, I could cross out the u's, right?
Yeah.
So they've basically taken this, multiplied top and bottom by u. What do we know about u?
I suppose that because it's a dimension of the triangle, it has to be positive.
Yeah, it's got to be greater than 0. And
so both answers are correct, but their answer accounts for that restriction?
I'm thinking. I'm not sure. I'm trying to think for a moment here. Let's see, do we know anything about quadrants? And why is the numerator absolute value and the denominator is not? The u in the denominator apparently can be negative. Do you have any answers on these?
I could send you the section where they explain it if you would like.
Yeah, that would help.
They don't explain that specific problem, but they go through an example.
Okay, they may give us enough information that we can figure out what they're doing.
Okay, I'll email it
to you. Yeah, email it to me. Do you email it to davidcowan1949@gmail.com? Or do you send it to
Yes.
David at, okay, that gets to me the quickest.
Okay, perfect.
49. The other one goes by way of my website and then gets transferred to me, and it can take a little bit longer.
Oh, okay. Perfect. All right, I've sent it to you. Yeah,
I prefer you put this as my email in your contacts. Don't even use the other one. It's not ever necessary.
Okay.
Sitting here trying to figure out why that would be. If you, now you could be negative. Let's talk about that for a second before I even look at your answers. The triangle I drew, u is always positive. But if I just look at this, that could be negative. I could certainly take the inverse tangent of a negative 1/2. Nothing wrong with doing that. So you can be positive or negative. Aha. For these purposes, you can be positive or negative.
Okay.
However, once I've drawn the triangle and I see that u is positive always, wow, somehow that translates to that. And this is still allowed to be negative. Let's see. Okay, yeah, let's, I think I've got this understood. Let me think about this for a second. If u was negative, that would be in the third or fourth quadrant, correct?
Yeah.
Because sine is always positive in the first or second. So cosecant is also positive in the first or second. So if u were negative, it would be in the third or fourth. And then if I'm taking the tangent and it's in the third, I'm going to have a positive answer. If you take the tangent of a third quadrant angle, you're going to get a positive answer. And does this give me that? Let's see, it gives me a positive numerator. If u were positive, then it would be in the first or second quadrant. So here, let's list this. If u is greater than 0, then it's first or second. If u is less than 0, it's third or fourth quadrants. And then I am taking the tangent of that angle. So in this case, if u were positive, I would be taking the tangent of a first or second quadrant. And if it's first, I need it to be positive. If it's second, I need it to be negative. So is that going to happen here? Let's see. I think so. If u is positive, that u is positive, that u is positive, that u is positive. So we get the same answer as we get with that expression.
Okay.
Let's assume u is in the second quadrant. Now I need this entire answer in blue to be less than 0 because I know the tangent of a second quadrant angle is negative.
Okay.
Okay. And so in that case, that would still be positive because u is positive. That would be positive. Doesn't give me a negative answer. Let me look at your explanations and see what I can determine here. Fortunately, I'm going to have to turn that one off for the moment to see it. Let me go up to my... I did not get... Oh, there it is. Yeah. Let's see. Do they have one? They don't show the absolute value one.
They don't show any of the absolute value.
But they are giving us the information we need, I think.
I'm just going to close my window real quick. There's like trucks driving by and dogs barking and people on the phone.
Go ahead while I take a look at this. Maybe I can figure it out. Lauren?
Yep, I'm here.
Okay, I wasn't sure if you were back yet. Okay, this is basically the analysis I was trying to go through with our tangent and cosecant. And let's see if we can do that. Let's see, our problem was the tangent of the inverse cosecant of u. Correct? Like
yes.
that? Okay. So what they did in this problem was examine the inside because after all, that's an angle.
Okay.
Okay. And they do notice the domain restrictions on u. Now, those domain restrictions do not apply to cosecants. It doesn't go between -1 and 1. It goes from negative infinity to, no, it does go from that. Yeah. Okay, excuse me. So let's do their exact analysis. Cosecant of u, excuse me, the cosecant of the angle, we'll call it theta, is equal to u, and you can still be positive or negative. It's the entire, so u would be greater than negative infinity and less than positive infinity. And alpha would be I think 0 to 2 pi. In other words, when I'm looking at just that part there, this is all I know.
Okay.
That u could be, because, hold on, I got this wrong. No.
I have the domain restrictions for cosecants in here somewhere.
Yeah, it's minus 1 to 1. It's the same as sine. In other words, here's what the sine curve, no, it's not 1 to 1. Excuse me. Let me draw a sine curve. Okay. And now let me draw the cosecant curve in a different color. Let me draw that in green. And the cosecant curve goes like this. With me?
Yes.
Okay. So the cosecant curve actually is not, please let me erase that. Yes.
So it's y greater than 1 or y less than negative 1?
Yes.
That would be the range.
Yes. That's where we're going to end up with that absolute value. So, so u is less than minus 1 and greater than 1. Strange way to write that. Yeah, let's write it maybe a little different here. So u is either greater than 1 or u is less than minus 1. And the angle theta, let's see, if u is greater than 1, then the angle theta is between, let me make a little bit more room underneath here so I can do this. So if u is greater than 1, theta is greater than 0, less than pi, because it's this range right here. With me?
Ooh, I think it might have gotten stuck.
Or what? Can you hear me?
Now I can. Yeah, you cut out for a few seconds there.
Okay. So you see what I've written over here on the right? If u is greater than 1, yeah, that's where we were making our mistake. I was assuming everything was 0, but cosecant cannot be between minus 1 and 1. Only can be less than minus 1 or greater than 1, greater than or equal to. And if it's greater than or equal to 1, it's in the first or second quadrant, just like sine is positive in those two quadrants. Now, if we assume that u is less than negative 1, then theta is greater than pi and less than 2 pi. So now what happens when we take the tangent of theta? Why do we not get 1 over the square root of u squared minus 1? Instead, we get absolute value of u over u. Is that bottom part u squared minus 1 or 1?
Yeah, it's u times u squared minus 1.
It is, because u was the hypotenuse, yeah.
Yeah, and I watched a video of someone doing the exact same problem online, and they got the same answer as you. And then I did it myself, doing it my own way, and I got that same answer as well.
Okay. So I think we can put this together. Clearly, I could multiply top and bottom by u. Let's do that. So that certainly is a possible answer.
Mm-hmm.
Now the question is why the absolute value sign on the top? Tangent of this angle, we don't know. Let's see.
Could it maybe be because if you don't have the absolute value signs there, you would never get a negative answer?
Possibly. You're right. That's it. Yeah, in other words, if I have 1 over the square root of u squared minus 1, that's a positive answer. So
yeah.
It gives us no way to come up with negative answers for the tangent of theta. Whereas by doing it this way, I come up with negative answers whenever u is negative. And u is negative in right there. So when u is negative, it gives us a chance to take the tangent of a fourth quadrant angle, which would be negative.
Okay.
And the absolute value is added so that the numerator is positive, the denominator is negative, we get a negative answer. And if u is greater than 1, then if it's second quadrant, we want it to be negative. Let's see, and if u is greater than 1, this is true. And then the absolute value doesn't matter. No, hold on. What if u is 2 and theta is in the second quadrant? Let's say u is right there. If you can see over on my drawing.
I do not see where you're drawing.
Really? You don't see the full screen? Huh.
I can just see your web browser open and the drawing on top of that.
You don't see your document underneath my drawing?
Oh yeah, I see the document underneath inside your web browser. Are you drawing right now?
Left or right? Do you see any of the pink that I've written on the right side? All those.
Yeah, I do.
You see those, but you don't see this graph that I've drawn on the left.
Yeah, I see a graph. I just don't see anything new written on it. Sorry, perhaps I missed that.
Let me write a number right there. You see what number I wrote? You're not seeing.
Oh, yeah.
Are you seeing?
Yeah, I just took 7.
Okay. Do you see where right to the left of 7?
The X?
Yeah, where I've circled it.
Yes, that I do see.
Okay. That would be a u of 2. Right? In other words, this is a u of. Oops, I have my eraser on. I didn't mean to have my eraser. Let me do that again. There's the sine curve, and then in green, there's the cosecant. And so I'm assuming that there's some value of u that's not 1, let's say 2, that would be about there. In other words, that's 1, that's 2. Okay?
Okay.
But we're in the third quadrant. So we know the tangent needs to be negative. Excuse me.
The third quadrant is positive.
We're in the second quadrant. This is pi, that's 0, it's 2 pi. So we're halfway. This is pi over 2. So we're in the quadrant between pi over 2 and pi, which is the second quadrant. And we know tangent needs to be negative. And yet, I have a u that is 2. Absolute value of 2 is going to be 2. That's going to be 2. That's going to be positive. We're going to end up with the tangent of theta being a positive number, even though theta is in the second quadrant and should be negative. Or the tangent of theta should be negative. So I definitely understand why this is written like that when u is less than -1. And it's in the third quadrant. Because that's the only, or it's in the fourth quadrant, because that's the only way you would get the tangent of theta to be a negative number. But it doesn't solve the problem of the tangent of theta being a negative number when u is in the, when u is like +2, which puts it in the third quadrant. So now I'm confused again. In other words, this is the correct answer for fourth quadrant and every other quadrant. But what about the second quadrant? In other words, when I'm in the second quadrant, u could be 2, right? If this is a correct graph that I've drawn over here on the left, u is 1 right here. So if you go up, it can be 2. It could be in the third or the second or the first quadrant, because that's also 2.
Is that a
That I think.
Is that a asymptote?
No, it's not an asymptote. There are asymptotes with this. In other words, you have an asymptote at 0, and you have an asymptote at pi, and you have another asymptote at 2 pi. So you do have asymptotes on the cosecant function. And that's why it'll go from 1 to infinity. It's this absolute value that puzzles me. And I see why it's needed whenever theta is in the second or fourth quadrant. In other words, you absolutely would have to have that. No, in the second, it's not going to give you a negative number. It should. We need it to give you a negative number. How do you get a negative number if it's in the second quadrant? In other words, what if u was this point right there, where it's +2, and it's in the second quadrant, so everything becomes plus in my final answer, and the tangent of theta would be plus, except it needs to be minus if it's in the second quadrant.
Yeah,
I'm missing something here. It's too bad they don't give you one of these for the reciprocal functions. It might be a little more illuminating.
Yeah, that's the only example they gave.
They do something interesting here that I like. Let me erase everything I have. That is alpha, and that is beta. So you actually have two angles there
Yeah.
being added. And so this first analysis here gives you that answer. And then beta is between 0 and pi. So the sine of beta is always greater than 0. So it gives you that answer. And then this would be just applying the sum and difference formula for sine to get that. And then that whole thing gets translated to u. U is sine of alpha cosine of beta, or uv is. And then that's cosine of alpha sine of beta. So I get their problem that you've sent me here. I understand it perfectly. But it doesn't help me on that absolute value. I may have to give that some more thought and maybe get back to you on that. I hate to ever say that, but
No, that's okay. I've been stuck on that one.
well, this is a strange one. Whenever you, in other words, whenever you have that, it's equal to 1 when u is greater than 0, and it's equal to -1 when u is less than 0, right?
Are you there?
Yeah, I'm still here. Can you hear me?
Okay, it cut out for a second.
Okay.
I'm wondering because when you take the square root, it could be plus or minus the square root. The answer could be plus or minus, right?
Not the way they've written it, no.
But it's implied that's positive?
Yes. In other words, the square root of 25 is 5. If I say x squared equals 25, and I take the square root of both sides, that's what's plus or minus 5. So
what if,
when you write it with a radical, you're assuming the plus. It's not, I can't just add a plus or minus to the 5 in the top. Because if I wanted to be the minus, I would put a minus in front of it. So it's just convention that if you have a radical sign, it means the positive. So in our previous problem, when we got u squared minus 1 times u, that is a positive number, no matter what.
Okay. I was going to say, if you kept the answer that we had, and you had 1 over plus or minus u squared minus, was that allowed? But you can't add the plus or minus in?
Well, the advantage of their answer is that instead of 1, they have absolute value of u over u.
Yeah.
And the absolute value of u over u is only equal to 1 if u is positive. If u is negative, then it's equal to minus 1. And that's why they've done that. The thing is that it seems to me in our problem that if u is positive and the angle that we're referring to is a second quadrant angle, you get a positive answer, regardless of how you write it. In other words, whether I've written it like this, or whether I've written it like this, can you see those?
Yeah.
On the left, it's always positive. So we actually know that that can't be right, because we do know that there are angles where the tangent of that angle is a negative number, right?
Yeah.
So we know the answer to the problem of the first two problems you sent me, the one on the right. We know this can't be the answer. 1 over, in other words, we can't do it just based on those two triangles. We have to take in domain and range restrictions. And it's the domain and range restrictions that turn the answer into this. Because this answer can be positive or negative. Whenever u is greater than 0, it's going to be positive. Whenever u is less than 0, it's going to be negative. Ah, I get it now, I think. Yeah. Let me go back to your page. I just had an insight here. I can figure out how to get out of this page. Oh, I hate the way this GoToMeeting completely takes over your desktop. You have to move stuff out of the way in order to see things. Now, let's see what I have to do to get back. Sure. I completely turned off my email. Let's see here. Let me just open it back up again. I'm beginning to understand it, and I think I can explain it. Let's see, I gotta go to that. How are you able to deal with the or is your school still open?
Homeschooled.
Oh, you're still homeschooled. Okay. I thought you had gone being homeschooled to a regular high school.
Nope.
Let's see. This is the picture I want. Right here. Yeah. Okay. Let's talk about the domain and range of the inside function. First of all, yeah, actually this is going to be the answer. I'm certain of it now.
Oh, wait. I think I see where this is going. Okay.
Yeah, here. In other words, if we talk about inverse sine, okay, let's just talk about inverse sine. Call it u. The domain of that is -1 to 1, correct?
Yes.
Okay. It's also, the range is actually not 0 to 2 pi. The range is -pi over 2 to, excuse me, wrong thing there, to pi over 2.
Wait, isn't that, I was thinking that was the other way around. That the domain was -pi over 2.
Here's
And the range.
here's the way they do it. If you take the sine curve, and you want to find out what the inverse of that function is?
Yeah.
If you took the inverse of the entire function, you wouldn't have a function. The only way to take the inverse of this function is by restricting its domain. And they restrict it from, this is strictly by convention. You could do it a different interval. But they restrict it to the fourth and first quadrants. And so now I have this that I can reflect over the line y = x to get the inverse function.
Okay.
And But the way you have to do it is by restricting the sign and not using the entire domain. In other words, if we want the inverse trig function to actually be a function, then you have to restrict the domain of the trig function itself.
Okay.
In other words, if I rotate that, that is one-to-one function, right?
Yeah.
Which means it will have an inverse, and the inverse will be a function. Whereas if I took the entire function from 0 to 2 pi, that is not one-to-one. Passes the vertical line test, but it doesn't pass the horizontal line test. So the same thing applies to cosecant. So the cosecant only goes from minus pi over 2 to pi over 2.
Okay.
Okay? And, that's why this works. Okay?
Yeah.
This is exactly why this answers the question. The tangent of this angle that I'm saying is inside the parentheses. If the cosecant, if the inverse cosecant is limited from minus pi over 2 to pi over 2, that's the fourth and the first quadrants, where tangent is positive in the first and it's negative in the fourth.
Okay.
It's going to be positive when, in other words, u is going to be greater than 1 when it's in the third quadrant, and u is going to be less than negative 1 when it's in the fourth quadrant. And this combination is going to match that. In other words, when u is greater than 1, we know we're in the third quadrant. Absolute value of u over u is going to be 1.
Okay.
And when we're in the fourth quadrant, the absolute value of u over u is going to be negative 1. And when we're in the fourth quadrant, the tangent of a fourth quadrant angle is negative. So this covers your third and your fourth quadrants only. But that's fine, because this angle theta has to be in the third or fourth quadrant. It can't be in the first.
Gotcha.
It looks like it can until you examine the domain restrictions on the inverse function. It's just like this sine over here has to also be, that angle theta has to be from minus pi over 2 also to pi over 2. But we didn't need any absolute values added there, because cosine is positive in the fourth and negative in the third. Opposite of this tangent problem. The tangent problem is positive in the third, negative in the fourth, so they throw in this absolute value of u over u to handle that.
That's tricky. I wonder why they wouldn't have given an explanation of that.
Very tricky, and I'm not proud of my explanation of it, because it's still hard to understand. But
it definitely makes sense, though. You just have to look at
the whole thing stems from this right there, the domain restrictions on the inverse trig function.
Yeah, I had kind of thought of that, but didn't put it all together.
Yeah, in problem 26, it didn't matter, because I don't need a absolute value of u over u. But in problem 27, it does matter, because I want tangent. The tangent is definitely negative in the fourth quadrant, and the only way I can get it to be negative is by putting the absolute value of u over u. That's negative. That's negative 1 in the fourth quadrant. so that it allows us to get the negative answer also. I had never realized that. I knew that, I had seen this multiple times, and I never realized why they did it until today.
All right, that makes sense to me. So
yeah, it all has, each inverse trig function has a domain restriction.
Yeah.
Tangent is, no, it doesn't, I don't think. But the sine and cosine both do. And since the cosecant is a reciprocal of the sine, both the secant and the cosecant do have domain restrictions. Now, let's just see if tangent does. The tangent curve looks like this.
I was thinking that tangent didn't have any domain restrictions except for like odd integer multiples of pi or something.
Let's see, the tangent goes from, no, I've drawn it wrong. I don't think it does have a restriction either, but I want to draw it right just to see. No, I had drawn it right. Yeah, the tangent of 0 is 0. So the tangent has asymptotes there, and it looks like this. And that is 1-to-1 from minus pi over 2 to pi over 2. And then it just does another period. In other words, the period of tangent is actually pi. It's not 2 pi like sine and cosine. So
that would be odd integer multiples of pi over 2.
Yeah, because the tangent curve is 1-to-1, I do not need to restrict it in order to take its inverse.
Okay.
I can't take the inverse of cosine curve because it's not 1-to-1. But if I restrict the domain in the cosine curve, you restrict it from 0 to pi, so that we're only dealing with this part of the curve. And notice that that green part of the curve is 1-to-1. Therefore, you can take the inverse of it. So when you're talking inverse cosine, you're talking from 0 to pi as the domain. When you're talking, actually, it's not the domain, it's the range. It's the range that is restricted. The domain of the cosine curve is restricted in order to produce the inverse cosine. So if I have the inverse cosine of some number u, and this being u, the u scale, it's not the inverse cosine, it's the range. No, the range isn't even restricted. The range is still going to go from -1 to 1. But u is restricted. No, u isn't restricted. The output is restricted. Now I'm a little bit confused. But I'm totally certain that that explains that over that. And
okay, I'm pretty sure somewhere in this book I have a list of the domain restrictions and ranges as well.
Well, I know the domain restrictions and the range restrictions, but it's the domain restriction on the primary function, the trig function. It's not really, in other words, if I graph that cosine, let's see, if I reflect it, I'm terrible at doing these. I really am. It's just my eye cannot see it. I cannot draw the reflection of that green line about the green curved line, about the green straight line. If I reflect this green curved line about the straight line, that's how you get the inverse cosine. Okay?
Okay.
And what is it going to look like? Something like that, we'll say. That looks like it might have a shot. Yeah, because this point becomes this point. That point's 0, and then these points down here go to the other side. So this is a reasonable approximation of inverse cosine of u, where now you know, when you take inverses, you switch the axis. So on the inverse cosine graph, u is the horizontal axis, and theta is the vertical axis. So if you were talking about this domain,
Are you there?
yeah, I'm just trying to figure out the answer to that question. This domain of the cosine function, in other words, what's the domain of u? -1.
I guess -1 to 1.
But on my drawing, it looks like it's 0 to something. Yeah. I'm not picking up something here. But
I think it should be okay.
yeah, I think you're fine now, as long as you realize that whenever you're dealing with inverse trig functions like cosecant or secant, that there's a domain restriction there.
Yeah.
It's not a domain restriction, it's a range restriction. This range, the domain of u, I believe, is probably all real numbers. No, that can't be right. The domain of u has got to be greater than 1 or less than -1. That's absolutely the domain of u. It's greater than 1 or less than -1. I don't know how that gels with this graph up here. It doesn't, but that's the range of that function. And so it's the range of that function that's important for the tangent, because now you're taking the tangent of an angle, only that angle is restricted to the third or fourth quadrant. And that's what's important to realize.
Okay.
When I substitute theta for cosecant, arc cosecant of u, I can substitute and call that an angle theta, but I have to be cognizant of the fact that theta can only be in the third or fourth quadrant. And because of that, I need this absolute value of u over u.
Okay. Yeah, that makes sense.
Okay. The same restrictions apply to the first one. It just doesn't require the absolute value of u over u to resolve it. It works out on its own. And mainly because cosine is positive in the first and fourth quadrants. In other words, this on number 26, that is restricted from the first or fourth. No. Yes.
That one should be
Only if it's
yeah, it should be first and fourth.
Well, correct. And then notice that the cosine of a first quadrant is positive and the cosine of a fourth is positive. So we're always going to have a positive answer, as that would imply.
Yeah.
On the tangent problem, since the cosecant is restricted to the third or fourth, well, the tangent of a third quadrant angle is positive, the tangent of a fourth quadrant angle is negative, hence the need for the absolute value of u over u. And that resolves it, because if u is positive, you get the third quadrant angle. If u is negative, you get a negative answer for tangent, and it's in the fourth quadrant.
Okay.
Okay. With that, I will let you go.
Perfect. I think,
Okay.
yeah, I think that helped a lot.
I'm happy to answer any other questions you have, but that explains a lot. Hopefully to you, but certainly to me.
Yeah, it does to me too.
Get it now. Yeah, why we need that absolute value of u over u.
Yeah, that makes sense.
Okay.
Huh. So the video I watched earlier had the wrong answer, huh? Just shows that Google isn't always the best place for math help.
I tell you where you might want to go is Wolfram Alpha.
Okay, yeah, I've heard of them.
Wolfram Alpha. I'm curious if they give you this same answer.
Okay.
Yeah, it should. Wolfram Alpha is like considered the top math database around. At least it has been for a while. There might be others that are better than it now, but yeah, I bet if you go into Wolfram Alpha and you type tangent of cosecant minus 1u, you'll get this exact answer that we got.
Perfect. I think I will probably take a look at that.
Yeah. And you're saying Google doesn't give you that?
Well, so I Googled it and I found a video of a guy working that problem out.
Okay. Okay.
And he got the original answer that you got and that I got.
Yeah. Yep. Okay.
Perfect.
Lauren,
thank you.
Good day. Be safe and stay well and avoid the coronavirus.
Yeah, you too.
Thanks. I'll talk to you next time.
Sounds good.
Bye-bye.